In our last section of this course, we're going to learn how to deal with fraction exponents. Specifically, exponents where you have a 1 on top and another number on the bottom. When you have something like a raised to the 1 over n, that may seem really complicated, but the meaning of that mathematically is the nth root of a. So the important thing is to notice the bottom number of that exponent tells you what type of root it is. So if we have 4 raised to the 1/2, a 1/2 exponent is the same thing as the square root. Usually the 2 is not written there for square roots, but here it's not wrong if you do, but usually it's just not written there. Here our answer would just be 2. Or if we have 27 raised to the 1/3, a 1/3 exponent would be a cube root. And the cube root of 27 is 3. Because 3 times 3 times 3 is 27. If we have x raised to the 1/5, this one we can't really calculate a numerical answer because it's a variable, but we can write it in root form. And since it's a 1/5 exponent, that would be the 5th root of x. Now let's take a look at this next one. It's very important that you understand something. Here, when it says negative 25 to the 1/2, it's almost as if the 25 to the 1/2 is in a parentheses. The way I like to remember it is if there's a negative at the front of the problem, then there's going to be a negative in front of the root. So here we would have negative square root of 5. Notice it's not the square root of -5. When the negative is at the front, the negative stays at the front. Oh, that should be negative square root of 25. Sorry about that. And we end up with -5 for the final answer. Now, in contrast, look at this next one. Here, the negative is in parentheses, and that whole parentheses is raised to the 1/3. That whole parentheses then goes under the root sign. And because it's a 3 on the bottom of that exponent, we have the cube root of -27y to the 6th. Now we take the cube root of the number part and the variable part separately. The cube root of -27 is -3. And you might remember from a previous section, to take the cube root of an exponential power, you divide the exponent by 3. So the cube root of y to the 6th, we do 6 divided by 3, we would have x squared. Now let's look at our next one, 7x to the 1/5. Think about what's being raised to the 1/5 here. X is raised to the 1/5, the 7 is not. So when we put this in root form, the 7 is just going to stay out front, and only the x goes under the root. And because it's a 5 in the denominator there, it would be 5th root of x. So 7 times the 5th root of x would be the answer. All right. Whoa. Here we go. Now comparing that with the next one, here we've got 7x in parentheses raised to the 1/5. The whole parentheses is raised to the 1/5, so the whole parentheses goes under the root. And we would get the 5th root of 7x. So make sure you notice the difference between those last two examples. It's very important. The next bit, we're working backwards. We're starting with the root form and writing it with fraction exponents. So our first one there, we begin with the 4th root of c to the 3rd. So here's what I do. I start with whatever's under the root, which in this case is c to the 3rd. But because it's a 4th root, I need to make the bottom number of my exponent a 4. So it'd be c raised to the 3/4. The next one, there's 11p under the root. Sometimes, just to make it easier on myself, I'll go ahead and put parentheses around it under the root. That's a good visual reminder for me that I'm going to have the entire 11p raised to a fraction. And as we said earlier, a square root is the same thing as the 1/2 exponent. So here we would have 11p in parentheses raised to the 1/2. Now for contrast, look at the next one. Here we have 11 square root of p. The 11 that's at the front just stays at the front. And then the square root of p is p to the 1/2. Notice the difference between those last two answers. The first one, everything in the parentheses is raised to the 1/2. The last one, only p is raised to the 1/2.